Hi everyone, my name is Yuan from Grouplands Research. Today I'm going to talk about my work, a user-centric study on related item recommendation. Related item recommendation is one of the most pervasive recommendation strategy. It shows the users items that are most relevant to what they're viewing. For example, Spotify displays the related artists at each artist page. And in our movie lens, it displays the top most similar movies to each movie. Fundamental to related item recommendation is the computation of the similarity between the items. So how to compute the similarity between two movies? Let's consider an example. The second movie is the sequel to the first movie. So they have same genre, leading actors, and protagonist. However, the plots of these two movies are quite different. Also, they have different ratings, director, crews, and reputations. So the question is, how similar are these movies from users' perspective? And how users are likely to recommend the second movie to someone who liked the first movie? These two questions are actually very important in designing the related item recommendation. However, they are actually the gaps in the current research. We found very little work on user-centric understanding of item similarity, and many work have used item metadata and user behavior to estimate the similarity and use it as an evaluation metric to evaluate their algorithms. And we also found that in some work related to music, people were asked to rate the similarity between the songs, but it's very rare in the music domain. So this brings our research questions. Which related item algorithms that best match user perceptions of relatedness and recommendation quality? And second, how should related item algorithms to be designed to improve user experience? We did an experiment on movie lens. First, we random sampled 100 popular seed movies, and we implement 6 related item algorithms to calculate their related neighbor movies to each seed movie. And finally, we deploy a user study, and we email the movie lens users to ask them to do a user survey. In the first part of the survey, we asked them their general opinions and expectations on the related item recommendation. And in the second part of the survey, we asked them to rate the similarities between the seed and neighbor movies. So this is the screenshot of the first part of the survey. So in this part of the survey, we asked them the questions like how often they look for a similar movie to watch, and we asked them to rate the importance of factors when they consider the similarity between the movies. We asked them whether in the similar movie sections, movie lens should prioritize the similar movies or the movie that fits their taste, and some other questions. For the second part of the survey, we implement 6 related item algorithms. First, we have baseline algorithms, which is random algorithms. Then we have rating-based algorithm, rating SVDs. This is just a standard rating-based collaborative filtering. And we have 2 click-based algorithms, click ARM and click VAX. So we just fit the user's clickstream session data into association rule mining and item to VAX algorithms. And finally, we have 2 content-based algorithms, tag Geno and review VAX. These 2 algorithms learn the relationship between the movies from movie tags and user reviews, respectively. So this is the screenshot of the second part of the survey. So we use each of these 6 algorithms to compute their related neighbor movies to each seed movies. If the users have rated both seed and neighbor movies in a movie pair, then we ask them 2 questions. First, how similar are these 2 movies? And second, would you recommend the neighbor movies to someone who liked the seed movies? So the result of these questions can answer our first question. We actually got over 27,000 movie pair evaluations, but we only keep the movie pairs that have at least 3 evaluations. So we end up having 21,000 movie pair evaluations from 36 users. And this is the distribution of aggregated user responses to the 2 questions in our second part of the survey, divided by algorithms. There are 5 levels in the response, from strongly disagree, which is indicated by the red, to the strongly agree, which is indicated by the blue. So we fit the aggregate user responses to each question to a cumulative link mixed model. And we found that the aggregate user responses for the movie pair that are generated by the movie VEX, which is the doctor applied on the review text, are significantly higher than any other algorithms in both questions. And the tech genome are the second best in these 2 questions. The review VEX and tech genome are both content-based algorithms, and we are interested to know that the characteristic of the movie pairs that are generated by each algorithms. This is the offline matrix describing the relationship between the city and neighbor movies. For example, in the first row, the movie pairs that are generated by rating SVD, which is the collaborative filtering, have the minimum differences in popularity. So after reading the whole table, it's actually not very surprisingly that we found the content-based algorithm, ReviewVex and TechGeno, did the best job in finding the movie pairs that have highest similarity in content-based metrics, such as genre, collections, and titles. On the other hand, the rating-based algorithm, rating SVD, did the best job in the behavior-based metrics, such as the popularity and ratings. And we believe that these factors are not equally important to the users when they consider the similarity between the movies. So this is the response for one of the questions in the first part of the survey. And there are 5 levels in the response, from not important, which is indicated by the red, to very important, the blue color. We can find that the genre, mood, plot, theme, and user ratings are the top 5 most important factors when user considering the similarity between the movies. And most of them are content-based factors. So the user response to the rest part of the survey can help us answer our second research questions. So about half of users saying that they often find a similar movie to watch after they watch a movie they enjoyed. And about 37% of users prefer movie lengths to prioritize similar movies in the most similar sections, as long as they fit their taste. And about 36% of users don't really care about that, whether the similar movie section should contain a different types of movies. But still, we have more people agree than disagree. We also collect some open-ended responses from the users. So many users has mentioned the problem about superficial similarity. So they're saying that they're very tired of seeing the remakes, prequel, or sequel movies in the recommendation list. Also, many users want more controllable similarity. They want to see more diversity in similarity. For example, they want to have a related item recommendation so that they can find the movies that have similar settings or mood. So to answer our first question, from the result, we can see that the content-based algorithms, the ReviewVex and TechGeno, have the highest score, not only in the similarity, but also in the recommendation quality. And to our second question, from our survey, we found that almost half of users often look for a similar movie to watch. So we can say that related item recommendation plays a really important role in the recommender system. And our movie lens users prefer the movie lens to prioritize the similar movies as long as if they fit their taste. And many users mentioned that they want to have more diversity in similarity and have a control on the different aspect of similarity. Also, this study is done on the movie lens, and we learn about how movie lens users perceive the similarities and recommendation qualities for the movies. So not all of our results can be transferred to other domain. So in order to design or improve the related item recommendation, I think it's always a good practice to do a user study to learn how your users perceive similarity or any other kind of a relationship between the items. We also released our dataset online. Thank you. Any other questions?
Okay, perfect timing. So we have time for questions.
Yes.
Yes, here.
Thank you very much for your talk. And so in your second user study, you presented 2 movie items recommended by different algorithms, right?
Yes.
So I have 2 quick questions. The first one is, did you ask the users if they had watched the movie, either or both?
Oh, yes, because we have their rating history. If the users have rated both movies, then we ask them these 2 questions.
Okay, so you selected only users who watched the movies, is that correct?
Yeah, yeah.
Okay, thank you. Yeah. That answers my second question as well, so
okay,
thank you.
Here in the middle, and then Chris.
Oh, yeah. I'm Gumon from Online. Thanks for the nice talk. And what do you think of the main reason for the dog-to-bag-based similarity measure can get a best result? Because in my thought that because oftentimes, you know, the Die Hard 1 and Die Hard 2, there are many related terms in both reviews, right? Like the name of the main actors or the name of the previous movie names, right? So what do you think that's the main reason? So is there any other reason you can think of?
The main reason, so the ReviewVex is like content-based algorithms. We apply dog-to-vec on the movie reviews. So I think in the movie reviews, it mix of very different aspect, like a plot, like their reputations or actors' names, or different things. So I mean that's my guess. Yeah.
Okay, thanks.
Okay. Chris there.
Yeah, thank you very much for your talk. That might be a little bit of a tricky question, but I mean, basically for evaluating your recommenders, you were showing 2 pairs. Yeah?
Yes.
So to the user. But you were not showing the whole list to the users. So you were not showing the seed item and 5 items, which you typically see in related item recommender systems. So I was wondering to what extent does then this evaluation method, with this pairwise comparison hold, if compared to when you would like to show all the items, like 5 or 10?
Sorry, I can't hear it very clearly. Are you asking that why?
So you were using evaluation protocol where you showed 2 items to the user, and you asked to what extent those items are similar to each other. Yeah?
Yeah.
Okay. But when you're going online, in MovieLens for instance, you see a seed item, and then you see like 5 or 10 similar items.
Yeah, right.
So, I mean, that's not quite the same, right? So in terms of evaluation, whether you show the seed item and 5 or just 2 of them.
Yes, because we want to make sure that the users have watched all of the seed and neighbor movies. So if we display like 5 or 10, I don't think that many users have watched all of those. Yeah.
Okay. Good. Let's discuss later. Thank you.
Okay. And here.
Chris from Hulu. Thank you for the great talk. There were 2 questions in your user study that I thought were really interesting. So of course there's the core of is this film similar to this other film? You also asked an explicit question, which is for users to self-report which aspects of content are most meaningful. Did you consider kind of the implicit? That is, you already have a lot of data on explicit feedback on which films are similar to which films. You also have the metadata for those films. Mm-hmm. So did you study at all, is there a difference between how users self-report, okay, I care most about genre, versus it was the times when the genres were common that people actually explicitly agreed that things were similar?
Oh, sorry, can you repeat your question?
Yeah, sure. Yeah. So in your user study, you asked users to rank, what are the aspects of content that are most meaningful in their decision-making process? So genre, actor, director, etc. They self-reported as most important. But the way that people self-report is sometimes different than what they actually care about.
Yes.
And you have a large data set of users agree that this film is related to this other film. You know from looking up the metadata for those films what the genres are. So did you consider like, did people report correctly? Like did they self-describe correctly which aspects of content they care about the most?
Yeah, we thought about these problems, and we believe that users may have a different attitude to these factors when they consider different movies. Yeah.
Okay, thank you.
So I have one question, and is if you control for a user expertise, because my feeling is that if you are an expert in movies, you might have certain perception of similarity based on very fine-grained aspects, some explicit, some implicit.
Yes.
But maybe newbies or just people getting into the MovieLens platform, whatever little sense of similarity might be okay for them. So did you check user expertise, background, and the effect on these results?
Yes, we thought about this problem. So we only keep the evaluation, the movie pairs that have at least 3 evaluations, and we take the average of them.
Okay, that at the item level, but on the user level, you check if the users were all of them or less an average amount of time previously in the platform, or you just randomly pick users in order to run this study?
Yeah, we just random choose a user.
Okay. Okay, let's thank our speaker.
Can I have a
You have last question. Yeah, it's okay. Yeah.
Zahra from Spotify. Thanks for the interesting presentation. I have a question about the part that users should have already seen both the movies. I wonder, in terms of like statistics, how much that was biasing the whole thing. The fact that the user has already seen the both movies, that there is a similarity, like prior already. I wonder, like, how many percentage of the ratings were saying that these are not similar. What was the statistics on that?
Can you repeat your question?
Let's say 100. You have 100 similarity rates. What was the percentage that were saying these are not similar?
Oh, sorry, I don't really get your question. Yeah.
Okay, let's say you have, your users have said these 2 different movies, if they are similar or not. It's either a 0 or 1, right?
It's either 0 or 1.
So what was your relevance answers?
Because we are past the time of questions, maybe
okay,
you can ask
offline.
in front of the poster. That would be
Sorry.
a better chance to ask more detailed questions. So let's thank our speaker and